Good day everyone, welcome back to our YouTube channel, and this video will cover week 4 of quarter 4. MELCs number 34 and 35 illustrates and proves properties of parallel lines cut by a transversal. Second, determines and proves the conditions under which lines and segments are perpendicular or parallel. Now let's talk about properties of parallel lines cut by a transversal. When we say transversal, a line that intersects two coplanar lines at two distinct points. So observe the given illustration. I have here a parallel lines, a line A and line B, and a transversal line. And to easily understand the properties of parallel lines, I have here another illustration. So I have here line L and line M and a transversal line which is line T. So to easily understand this, I have here the interior angles. Angle 3, 4, 5, and 6. We also have exterior angles, angle 1 and angle 2, and another exterior angles, angle 7 and angle 8. Next is the interior angles, angles that are in between the two lines cut by a transversal. So I have here the illustration, and here are the interior angles. Can you give all the interior angles? Alright, we have angle 3, angle 4, angle 5, and angle 6. Next is the exterior angles, angles that are outside the two lines cut by a transversal. From the word outside, so here is the illustration. So here. So the exterior angles are angle 1, angle 2, angle 7, and angle 8. So those are the exterior angles. Next is the alternate interior angles. When we say alternate interior angles, this is the angles located inside a set of parallel lines and on opposite sides of a transversal. So in this given illustration, the alternate interior angles are angle 3 and angle 6. What else? We have angle 4 and angle 5. Now let's proceed to corresponding angles. Angles that can overlap, or the two angles in the same relative position on two lines when those lines are cut by a transversal. So in this given illustration, the corresponding angles are angle 1 and angle 5. Next, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8. Alright. Same side interior angles are angles located inside a set of parallel lines and on the same side of a transversal. So here, the same side interior angles are angle 4 and angle 5, and angle 3 and angle 6. Next, same side exterior angles. So these are the angles located outside a set of parallel lines and on the same side of the transversal. So here, angle 1 and angle 8, and here angle 2 and angle 7. Now let's talk about postulate. When two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. Let's take an example. Given line L is parallel to line M, and N is a transversal of line L and M. prove that angle 3 is congruent to angle 5 and angle 4 is congruent to angle 6. So here is our plan. Angle 1 and angle 5, angle 2 and angle 6 are what type of angles? Are they congruent? Alright, so that is corresponding angles and they are congruent according to the definition. Next, how about angle 1 and angle 3? Angle 2 and angle 4. Are they congruent? Yes. Why? Because they are vertical angles. Always remember, vertical angles are always congruent. Next, did you arrive at desired conclusion? Alright, let's see. Now, let's prove this statement using the table of proof or the two-column proof with the statements and the reasons. So, what is our first statement? Alright, given the information here, L is parallel to M. The reason is given. And we have two plans, right? So for statement number 2, angle 1 and angle 5, angle 2 and angle 6 are pairs of corresponding angles. The reason is definition of corresponding angles. And we all know that corresponding angles are always congruent. So based on statement number 2, we have angle 1 is congruent to angle 5, angle 2 is congruent to angle 6. The reason is postulate. If a transversal cuts parallel lines, corresponding angles are congruent. Now let's proceed to our second plan. Angle 1 and angle 3, angle 2 and angle 4 are pairs of vertical angles. The reason is definition of vertical angles. And we all know that vertical angles are always congruent. So based on statement number 4, we have angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. The reason is vertical angle theorem. Now we can conclude that or prove that angle 3 is congruent to angle 5 and angle 4 is congruent to angle 6. The reason is transitive property. Alright? Theorem. If two parallel lines are cut by a transversal, then the alternate interior angles formed are blank. Alright. Congruent. Let's practice another example given L is parallel to M and is a transversal of L and M. Prove that angle 1 is congruent to angle 7, angle 2 is congruent to angle 8. Again, let's make a plan here for us to easily prove this statement. So for our plan, angle 3 and angle 7, angle 4, and angle 8 are what type of angles? Very good. They are corresponding angles. Are they congruent? Alright, yes. How about angle 1 and angle 3? Angle 2 and angle 4. Are they congruent? Yes, and they are vertical angles. We all know that vertical angles are always congruent. Now let's use the table of proof. For our first statement, given here, the given information, L is parallel to M. The reason is given. And for our second statement, let's use our plan. So, angle 3 and angle 7, angle 4 and angle 8 are pairs of corresponding angles. The reason is definition of corresponding angles. And we all know that corresponding angles are always congruent. So based on statement number 2, we have angle 3 is congruent to angle 7, angle 4 is congruent to angle 8. The reason is postulate if a transversal cuts parallel lines, corresponding angles are congruent. Next, remember our plan. Angle 1 and angle 3, angle 2 and angle 4 are pairs of vertical angles. The reason is definition of vertical angles. And we know that vertical angles are always congruent. So based on statement number 4, we have angle 1 and is congruent to angle 3. Angle 2 is congruent to angle 4. The reason is vertical angle theorem. Therefore, angle 1 is congruent to angle 7. Angle 2 is congruent to angle 8. The reason is transitive property. Alright? Now, theorem, if two parallel lines are cut by a transversal, then the alternate exterior angles formed are congruent. Next example, given K is parallel to S, P is a transversal of K and S. Prove that angle 3 and angle 6 are supplementary. Angle 4 and angle 5 are supplementary. So here, two angles are said to be supplementary if they add up to 180 degrees. Alright? In this example, let's identify the missing statement and reason. So for our first statement, we have K is parallel to M. The reason is given. How about the statement number 2? The reason is definition of corresponding angles. Observe the given illustration for you to easily find out the missing statement. Alright, we have angle 1 and angle 5, angle 2 and angle 6 are pairs of corresponding angles. How about the reason for the third statement? Which is angle 1 is congruent to angle 5, angle 2 is congruent to angle 6. Very good. We have postulate if a transversal cuts parallel lines, corresponding angles are congruent. How about the missing statement for number 4? We have the reason definition of vertical angles. Okay, measure of angle 1 is congruent to measure of angle 3. Measure of angle 2 is congruent to measure of angle 4. How about the reason for our fifth statement? Angle 1 and angle 4, angle 2 and angle 3 form a linear pair. Okay, definition of linear pair. How about the sixth statement? The reason is linear pair postulate. Linear pairs are supplementary. Our sixth statement is angle 1 and angle 4, angle 2 and angle 3 are supplementary. Next, measure of angle 1 plus measure of angle 4 is equal to 180 degrees. Measure of angle 2 plus measure of angle 3 is equal to 180 degrees. What is the reason? Alright, definition of supplementary angles. How about the statement for number 8? The reason is substitution principle. Okay, so it is based on statement number 7. Measure of angle 5 plus measure of angle 4 is equal to 180 degrees. Measure of angle 6 plus measure of angle 3 is equal to 180 degrees. Now we can prove that angle 3 and angle 6, angle 4 and angle 5 are supplementary. What is the reason? Alright, definition of supplementary angles. Okay? Alright, so now you can pause this video para mas makita nyo yung lahat ng information for this given example. And for the theorem, if two parallel lines are cut by a transversal, then all pairs of interior angles on the same side of the transversal are supplementary. Next, given A is parallel to B, cut by a transversal T. Prove that measure of angle 1 plus measure of angle 7 is equal to 180 degrees. So what is our first statement? Alright, given the information, A is parallel to B. The reason is given. And what is the reason for our second statement? Angle 1 and angle 5 are pairs of corresponding angles. The reason is definition of corresponding angles. How about statement number 3? The reason is postulate if a transversal cuts parallel lines, corresponding angles are congruent. So the statement number 3 is angle 1 is congruent to angle 5. So that is based on the statement number 2. How about the reason for statement number 4? Measure of angle 5 is congruent to measure of angle 8. That is definition of vertical angles. If the statement number 5 is angle 5 and angle 7 form a linear pair, the reason is definition of linear pair. And what is the sixth statement? If the reason is linear pair, postulate linear pairs are supplementary. The reason is angle 5 and angle 7 are supplementary. And now we can conclude that measure of angle 5 plus measure of angle 7 is equals to 180 degrees. And the reason is definition of supplementary angles. Therefore, we conclude that measure of angle 1 plus measure of angle 7 is equals to 180 degrees. The reason is substitution principle. In this example theorem, if two parallel lines are cut by transversal, then all pairs of exterior angles on the same side of the transversal are very good. Supplementary. Word problem. One of the best experience when you go to Tagaytay is to try or experience the zip line. A zip line is a very strong cable between 2 points with a pulley attached to it. This could be used as a means of transportation. The zip line in the figure goes from a 20-foot tall tower parallel to a 15-foot tall tower, 150 meters apart in a slightly inclined ground as shown in the sketch. Note, tension of the rope is excluded. So here is the sketch. The question is, what kind of angle pairs are angle M and angle A? And angle MHT and angle ATH. Observe the given sketch. Alright, angle M and angle A, angle MHT and angle ATH are both interior angles on the same side of transversal. Now let's find the measure of each angle. Angle M plus angle A is equal to 180 degrees. So M is 2z plus 15 and A is 3z. Let's substitute it to the given equation. So we have 2z plus 15 plus 3z is equal to 180 degrees. Let's combine like terms. 2z plus 3z is 5z plus 15 equals 180. Now let's use addition property of equality, or let's isolate 5z. So 5z is equal to 180 minus 15. 180 minus 15 is equal to 165. So we need to divide both sides by 5 to get the value of z. So we have z is equal to 33. Now since we already know the value of z, we can now get the measure of angle M. So we have angle M is 2z plus 15. So let's substitute 33 to the given equation. So angle M, 2 times 33 plus 15. So 2 times 33 is 66 plus 15. Angle M is equal to 81. Alright, so this angle is 81. Next, let's find the measure of angle A. So angle A is 3z. So let's substitute the value of z. So 3 times 33 is equal to 99. So the measure of angle A is 99. So angle M is 81, angle A is 99. Next, let's find the measure of these two remaining angles. So angle MHT, or this angle, plus measure of angle ATH, or this angle, is equal to 180 degrees. So let's find the value of y. So let's substitute the given information. So angle MHT, y plus AT plus y is equal to 180 degrees. So let's combine like terms. Y plus y is equals to 2y plus 18 is equals to 180 degrees. Let's isolate 2y or use addition property of equality. So we have 2y equals to 180 minus 18. 180 minus 18 is equal to 162. Let's divide both sides by 2. Y is 81. So since we already know the measure of, or the value of y, we can now get the measure of this angle. Alright, so angle ATH, or this angle, is equal to y. Let's substitute. Y is 81, so this angle is 81. Alright, next, how about this angle? So angle MHT is equal to y plus 18. Let's substitute the value of y. So y is 81 plus 18 is equal to 99. So the measure of this angle is 99. So here is 81 and here is 99. Alright, and if we add up these two angles, the sum is 180 degrees. The same with these two angles. Alright? Remember, properties of parallel lines cut by a transversal. First, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Second, if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. If two parallel lines are cut by a transversal, then the interior angles on the same side of a transversal are supplementary. And if two parallel lines are cut by a transversal, then the exterior angles on the same side of the transversal are supplementary. Here are some conditions that guarantee parallelism. Two lines or line segments are parallel if and only if they are coplanar and do not intersect. Given a point and a line not containing it, there is exactly one line through the given point parallel to the given line. If two lines A and B are cut by a transversal line M, then it forms 8 angles. If two lines A and B are cut by a transversal line M and a pair of corresponding angles are congruent, then the lines A and B are parallel. This postulate of Euclid.